before production starts. The system finalizes head shape, torso geometry, hand posture, foot angle, facial symmetry, and micro skin texture using high-precision digital modeling software. Once approved, the digital file moves directly into automated tooling, where CNC machines cut precision mold components for each body section. Separate mold cavities are engineered for the head, torso, limbs, hands, and feet, with gates, vents, and seam paths built in. Laser-guided metrology systems inspect every mold surface to verify alignment, cavity depth, and parting line accuracy before production begins. Internal heating channels are also tested automatically because stable mold temperature is essential for liquid silicone to cure evenly. When tooling passes inspection, robotic transfer units load the molds into automated production cells and lock them into position. In the raw material zone, 2-part liquid silicone is pumped from sealed drums into a closed metering and feed system. Precision pumps deliver Part A and Part B at controlled ratios, keeping the material stable, repeatable, and protected from contamination. Computerized dosing units inject skin tone pigments into the silicone stream, building a consistent base flesh color before molding even begins. Any variation in pigment flow is detected instantly by sensors, allowing the system to correct or reject the cycle automatically. The silicone and pigments then move through a static mixer, where the material becomes fully uniform just before injection. Because the silicone starts reacting once mixed, the feed path is temperature managed to keep the material stable before it reaches the mold. Before injection, the mixed silicone enters an automated vacuum chamber that removes trapped air and protects delicate surface detail. Under vacuum, hidden gas expands and escapes, leaving a smoother material that can form realistic skin without pits or voids. Once conditioned, the silicone moves into robotic injection units that deliver the material through sealed nozzles into heated mold cavities. Injection speed, cavity pressure, and fill timing are controlled in real time to prevent turbulence, short shots, and distorted detail. As the mold fills, the first silicone reaching the surface captures pores, lip texture, eyelid folds, and finger creases. Automated flow control ensures the material reaches every thin section evenly, including the nostrils, fingertips, ears, and nail beds. During the cycle, robotic insertion units place internal support components and weighted elements into programmed positions inside the mold. Sensors verify insert placement before the cavity closes completely, ensuring the silicone body forms around a perfectly aligned internal structure. With filling complete, the mold enters the curing phase, where controlled heat transforms the liquid silicone into elastic solid geometry. Thermocouples and software regulate temperature continuously, because stable heat is critical for softness, strength, release, and dimensional accuracy. As curing progresses, the material cross-links inside the cavity, holding every anatomical contour designed in the original digital model. When the cure cycle ends, robotic demolding systems open the molds and lift the fresh silicone sections out carefully. Soft contact grippers protect flexible parts during extraction, especially around the fingers, lips, eyelids, and other delicate areas. The demolded parts move along a stabilization conveyor, where the geometry cools and settles before automated finishing begins. Each section is digitally tagged, linking it to its material batch, mold cycle, cure history, and downstream inspection record. Next comes robotic deflashing, where machine-guided cutting heads remove thin flash formed along mold parting lines. The trimming system scans the seam path first, then follows it automatically without damaging surrounding skin detail. Around the lips, nostrils, fingers, toes, and eyelids, the cutters slow down for finer edge control and cleaner results. After trimming, the parts enter a surface inspection tunnel, where cameras look for flash residue, voids, short fills, and distortion. Multi-angle imaging compares every component to a digital master, rejecting any part that misses the required realism threshold. Approved sections now move into robotic assembly, where the torso, head, arms, and legs are aligned around the internal frame. Articulated robots rotate each part into exact orientation, then lock the support structure using torque-controlled fastening systems. Assembly software also verifies balance distribution, ensuring the torso mass and limb weight match the intended body behavior. Once structure is complete, the figure moves into the surface finishing line, where visual realism is built through automation. Robotic spray units apply translucent silicone-safe tones in layers, creating base color, warmth, shadow, and skin depth. The first pass evens the tone, while later passes deepen contours around the cheeks, neck, joints, and hands. Machine vision locates every contour automatically, guiding the spray path so the color lands exactly where anatomical depth is needed. A second finishing module adds subtle blush to the cheeks, knees, elbows, fingertips, and heels for more natural skin variation. Another system prints faint blue-green vein patterns, then softens them beneath translucent surface layers to mimic real skin depth. Lip shading, eyelid transitions, nail tint, and crease definition are all applied by programmable micro-finishing heads. These controlled layers transform the molded body from uniform silicone into a surface that reads more like living skin. Mapped density patterns. The hairline receives lighter density first, then fuller placement toward the crown and rear scalp for natural distribution. Insertion angles are adjusted automatically so the hair falls in realistic directional flow instead of standing unnaturally upright. Secondary grooming robots trim the fibers, shape the style, and remove loose strands for a cleaner final presentation. If required, micro-placement units also install eyebrows and lashes with the same programmed precision used across the line. At this stage, the face becomes visually coherent, with balanced skin tone, aligned eyes, softened hairline, and completed outer detail. The assembled figure now enters articulation testing, where robotic manipulators lift and rotate the body through programmed motion checks. Sensors confirm that the head angle, limb alignment, internal supports, and weighted balance all remain within design tolerance. If any section drifts out of neutral position or responds incorrectly, the system diverts the unit automatically. Accepted figures continue into the final machine vision tunnel, where high-resolution cameras scan every visible surface and feature. The system checks skin tone consistency, seam visibility, hair distribution, eye symmetry, paint quality, and overall surface finish. Because lighting is controlled, cameras can detect flaws invisible in normal conditions and judge the figure against a master standard. Once approved, the doll enters the final cleaning cell, where automated air jets remove dust and loose fibers. Soft contact robotic wipers clean the face, torso, hands, and feet without damaging the finished skin surface. A last optical scan confirms the body is clean, symmetrical, and presentation ready before packaging begins. In the packaging zone, robotic arms place protective coverings around the face, hands, feet, and styled hair. The figure is lowered into a fitted inner tray designed to stabilize the body and prevent pressure damage during shipping. Automated box-forming equipment closes the package, inserts model data, seals the unit, and links it to its production history. From digital design to sealed box, every stage in this factory uses automation to transform liquid silicone into a lifelike humanoid form.